Okay, a lot of my students are really curious to see how I would approach this problem if I were a student. I did have several students who told me that they had difficulty with it, and then I had some other students who said they didn't really have difficulty, but they wanted to see the approach I would take with it. Well, the first thing I want to do is look at what it's asking for, and then come up with a plan that I can work out step by step. And when I look at my shape here, it looks like a triangular prism. And it says A is the triangle that forms the base of the prism, equilateral, isosceles, or scalene. I'll go ahead and address that right now. I'm going to use what I know about the definitions of equilateral, isosceles, and scalene to answer this one. Now, equilateral means that all the side lengths are the same. But when I look at this triangle that makes this base here, and I know that the triangle behind here is congruent, it tells me that this side length is 12 centimeters, this side length is 12 centimeters, but this length is 17. So I know it's not equilateral because all side lengths are not equivalent or equal. Isosceles means that two sides are congruent, and that's what this is. This is an isosceles triangle because we have this side that's 12 centimeters, we have this side that's 12 centimeters, so we have two sides that are congruent, so it's isosceles. And just to mention scalene since it's here, scalene means that all the side lengths are different. Now, as I look around my classroom, I do have students in here. I hope that they're paying attention, that they're being active listeners, they're not fidgeting with anything. They're sitting up, they're sitting still, they're looking at what the speaker is directing them to look at. And in this case, it is the Prism board. Now, the camera actually is pointing directly at my desktop, my computer, but everybody else should have a good view of the Prism board. B says write a numeric expression to represent the surface area of the figure. C wants to know what is the surface area of the figure. And D wants to know how did the number of congruent faces on the figure help you write your numeric expression. Okay, the very first thing I'm going to do, and I do this always, I'm going to make a net. And when I make that net, it's going to ensure that I don't leave any of the faces out, so I can come up with a numeric expression that is complete. Doesn't leave anything out. So the first thing I'm going to do is, I know that this triangular prism is sitting on a rectangular face. So I'm going to put a rectangular face here, which represents the bottom here that you can't really see, but we do know that this edge of this rectangle is going to be 17 centimeters, and this length is going to be 10. Now, I'm going to go ahead and put this rectangle, I'm going to set this rectangle right next to it. Okay, right next to it, and I apologize that my little sketch here is a little messy. I know that it is 12 centimeters this way, and it's 10 this way, so I'm going to go ahead and put 10 there. Now, this side, I'm going to connect it to the bottom. I could put it over here, but I'm going to connect it to the bottom. And this side, I'll just set over here. And I know that it's 12 centimeters this way, and it's 10 centimeters this way. Now here we have this isosceles triangle, and I'm going to put that triangle this way. And I know that the base is 17 because it says it's 17 here. And I'm interested in the height because our formula for finding the surface area of a triangle does require that we know the height. And it says it's 8.5 centimeters here. So I'm going to go ahead and put a little dotted line and then 8.5 centimeters. And I'm not putting the units of measure in this part here because this is just to help me see what faces I need to make sure I account for. And this is not really going to be something that the person grading my work would probably even see. I mean, it's not like this is a requirement to do this net, it's just something that helps me. And I'm going to go ahead and put another equilateral triangle here because it's the one in the back. Not equilateral, I'm sorry, isosceles. It's not equilateral because this base is 17 and the sides are 12 and 12, so it's isosceles. And the height is just like this one here, 8.5 centimeters. Now I have to come up with a numeric expression, and I'm going to make sure I don't leave anything out. I'm going to change the color of my ink to blue. Now, I do have a rectangle here that's 12 by 10, and I have one here that's 12 by 10. So I'm going to start off by saying 2 times 12 times 10. And I'm going to add that to, and that's got this one and this one taken care of. I'm going to add it to this rectangle here, and this rectangle is 10 by 17 times, and I'll put this in parentheses, 10 times 17. And then I've got these two triangles that are exactly the same. And I'm going to say then plus 2, and the formula for finding the surface area of a triangle is area equals 1/2 base times height. So I'll say 1/2, and the base is 17 times the height, which is 8.5. And that's got this and this taken care of, and I got that one right here. So that is my numeric expression to represent the surface area of the figure. Now, there's other ways I could have written it. Because of the commutative property of addition, I could have this grouping and this grouping, and I could have them in different orders, things like that. I could do a lot of things differently, but as long as students have a numeric expression that's equivalent to this one, they'll be okay. Now it says, what is the surface area of the figure? So I'm going to go through and I'm going to find the surface area of my figure. I'm going to go ahead and do the math part, some of the computations very quickly if I can. So 12 times 10 is 120. 120 times 2 is going to be 240. This will be 170. Now, one of the things I'm going to do here, anytime you have to times 2 and then you got a half here, I would just say, I would just focus on the 17 and this 8.5. I wouldn't even worry about this because that will cancel each other out. They'll cancel it out. So 17 times 8.5, let's do it the standard algorithm. Placeholder. Okay, now I did not worry about my decimal point at all when I was setting my problem up. The only time you have to worry about your decimal point is when you're adding decimals or subtracting decimals. When you're multiplying decimals, you don't have to worry about that until you get your product. And here's my product. And I see that I have one digit to the right of a decimal, so I have to have one digit to the right of this decimal. So that's going to equal 144.5 or 5/10. Now I just have to add all that together. And I can add that together pretty easily. I'll just start over here. 144.5. Now it's understood there's a decimal point here and 0, 0, so I'll put a 5 here, my decimal here. 1, 3, 4, 5. So I got 554.5 centimeters, and we're dealing with surface area, so that's going to be square. So the answer for this problem is 554 and 5/10 centimeters squared. Now, how did the number of congruent faces on the figure help me with my expression? Well, it helped me because I had two rectangles that were the same. All I had to do was just say 2 and put that in parentheses here. I had a student ask me earlier, they said, do you have to put the 2 outside the parentheses? You could put the 2 inside. I mean, check this out. If I do the order of operations the way it's supposed to, 12 times 10 is 120. 120 times 2 is 240. If I start here and work my way from left to right, 2 times 12 is 24. 24 times 10 is 240. So that would work. But because I had 2 rectangles that were congruent, it saved me having to write down both expressions. Also, because I had 2 triangles that were congruent, I didn't have to write both of them. I just had to say 2 times the height and the base. So it was really easy because you have more congruent shapes. It's really easy to write your numeric expression, kind of combining some expressions, multiplying them by 2, whatever. It kind of makes it a little bit easier that way. Now, I used what I knew about definitions of equilateral, isosceles, scaling. I used what I know about formulas for finding the surface area of shapes. I used what I know about nets. You can almost call this, making this net, a model. I did step one, made a plan, worked out step by step. I mean, I did all kinds of math practices with this. And I showed my process, and I showed my answer. Boys and girls, what grade does Mr. Hall deserve?
100.
100, okay. Now, those of you who missed it, and you say now that you realize where you messed up, before we even checked, some of you were saying, I see what I did wrong. Has this helped you? Who wants to share? All right, Gracie, how did this help you, seeing me do it?
Because I realized that whenever you find the surface area of a triangular prism, you have to find the area of a triangle. But I found for the triangle, I did 17 times 12. But now I see that's wrong because you have to do a half times the base times the height.
Okay, so you got your little formula a little bit confused there. Okay, all right. I'm glad that this did help you, Gracie. I hope this helped everybody.